So we're going to check out this problem right here first. A baby weighs 18 pounds at her 4-month appointment. 6 months later, she weighs 24 pounds. By what percent did the baby's weight increase? So we're going to go over this problem. All right, so this problem. Well, first, of course, percent proportion is your percent over 100 is equal to the amount of change from your original to your new over the original amount. Okay, so we're going to have to find the percent of change, or we're going to have to find the amount of change, and then the original amount to find the percent of change. Okay, so the original amount was 18 pounds. The baby started at 18 pounds, and it went up to 24. So remember, I told you, always put the bigger number first, just so we can avoid negative numbers. But the original amount was 18. So I'm going to move my camera down so you guys can see the whole problem as I do the work. So 24 minus 18, can I get an answer? I can't hear y'all. Duh, it's camera. All right, so this would be 6 over 18. We don't know this percent, so instead of putting that percent sign, I'm going to change that to an X. We don't know that. It's a terrible line right there. Then we're going to cross it up, okay? Just cross them up, give them a little shimmy. All right, so 6 times 100 is 600. I'm going to move my work right over here. And we have 18x. And so then we're going to divide 600 by 18. And when we divide 600 by 18, we get that x is 33.3. Now remember, what did x represent in this problem? Well, it represented the percent of change that the baby had went through. So, of course, our answer here would be a 33.3% increase. Okay, so the baby's weight had went up by 33.3%. So that would be the answer to that first problem, 33.3% increase, percent of change. So now I'm going to do a percent of error problem. I'm going to look at number 8 because it has you working kind of backwards. It's like number 2 from the video. A postage box should weigh 1 pound. If there's a 5% error on the weight, what is the range acceptable for the weight? So we're going to talk about how to solve this one if I'm trying to find the range. Remember, we went through one already, but I realize you may be struggling a little bit, so let's go through another one. All right, so of course this is percent of error. So the formula is percent over 100 equals approximate minus the exact, but the absolute value of that, so the positive version, over exact. Okay, so we're going to be looking into how to solve this. Let me move it up so you guys can see me talking. But we're going to talk about how to solve this. So they gave me the percent. So let's go back to that problem. So that problem says the 5% error. So in the percent spot, I'm just going to put a 5. Do not put a percent sign with that. Remember, I can't tell you enough. You cannot put a percent sign here because percent means over 100. So if I put a percent sign there, I'm literally saying over 100 over 100. I mean, I'm calling this thing old twice. But I don't need that percent sign there. I just need that, okay? When they talk about range, they're talking about this up here, okay? We don't know that. So remember, when we don't know something, we put an X. And they also give us the exact amount. So let's go back to the problem. Right there, should weigh 1 pound. So that's saying this is what it exactly should be. But there's a 5% error in that. So our exact is just 1 pound, just one. All right, so now we cross them up, give them a little shimmy, multiply those two, okay? And so 5 times 1 is, of course, 5. And then 100x. So now we're going to divide by 100. And what do we get here? We get, move it up here, 5 over 20 is actually not a whole number. Okay, so x equals 1 over 20 or 1/20. Okay, so that's the acceptable range. Okay, let's change that to a decimal. So that'd be 0.05. Okay, so what that means is we can be within 0.05 of our exact amount, which was 1. Okay, so let's subtract 0.05 from it. Well, that's 0.95. And then let's add 0.05 to it. And that's 1.05. So our acceptable range We can go down to 0.95 or we can go up to 1.05. That's the acceptable range for this problem. So this postage, it was talking about a postage box. Remember, postage stamp, shipping a box. It said a postage box should weigh 1 pound. If there's a 5% error on the weight, what is the range acceptable weight? So the range here would be from 0.95 pounds all the way up to 1.05 pounds. That's the acceptable weight on this problem. So that's how you do it if you're trying to find a range with percent of error. Those are probably the toughest problems because we don't just get the answer straight out. We have to do a little math after getting that answer. So this is what we're going to be working on. So I'm actually going to do a simple interest problem next. So if you don't need a simple interest problem, you're fine exiting the video. But I'm going to do one of those next. All right, so now let's look at a simple interest problem. This is number 3 on the practice problem. Miss Baxter deposits $2,000 in an account that earns 5% interest. How much is Miss Baxter's investment worth after 8 years? I picked this problem for a reason because the question part, Miss Baxter's investment worth after 8 years, that is a big deal, okay? Because a lot of you probably you probably have the answer, you just don't know it. Or you have part of the answer, and you just don't know it yet. But we're going to go over this one together. So Miss Baxter deposits $2,000. So $2,000 is, of course, our principal amount. Okay. So let's go ahead and put the formula down. I equals P R T. Okay. So interest equals principal times rate times time. All right. So I'm going to put my I P R T over here to the side. And let's write down what we know. Well, I told you she deposited $2,000 into her account. So that's your principal. Let's go back to the problem. Our interest rate is 5%. Okay. So our rate is 5%, but I'm going to go ahead and change that to a decimal. So remember that's 0.05. You move the decimal place 2 places to the left. And then how much time had passed? 8 years. Okay, because that's from the question. Sometimes it's not in the part before the question. Sometimes it's in the question. So it tells us 8 years. And we do not know this. So this is going to be our X. Okay, so we don't know interest, but we do know principal. We know the rate. And we know the time. Okay, so we're going to multiply all those numbers. So I'm going to grab my calculator. 2,000 times 0.08 or 0.05 times 8, and you get 800. Now, this is where a lot of you probably have the answer. You're like, Mr. Tedder, I got that answer. Yeah, you got that answer, but that's not what the question asks. The question is asking, how much is her investment worth after 8 years? The investment itself is her principal plus the interest. Okay, so remember, she had already had $2,000 in there. She just added 800. So that thing is worth 2,800 after 8 years, not 800. It said how much is it worth? You got to take the interest and add it back to the principal. Okay, so make sure you understand what the problem is asking. It's not just asking for interest. A lot of us get this answer and we're like, oh, I got the answer. Yes, yes. And great, that's great, but that's not what the question asks. Okay, hate to break your achy break your hearts, but that's not what the question asks. So make sure we know what the question's asking. All right. So if you still have questions, I promise I'll help you as much as I can. We're going to be doing this a lot over the next little bit of time, but I want you to try some more problems. Okay. At this point, I've helped you a little bit more. So let's go try some more, see if we can get to that finish line, get to that goal we want, which is able to do these types of problems, because you're going to see a lot of them on the check-in. But if you have more questions, ask Mr. Tedder.